Okay. All right, here we go. If you have uh um if you have a point anywhere on the coordinate system, right? So for example, here, okay? So if we have a point anywhere here, let's call that P, okay? And suppose that point is at 3 comma 7, okay? Now, I can connect that point to the origin using a line, right? But in math, we usually use array, and we call it a radius, right? So that's what a radius would look like, okay? So we're going to call that the radius. Now, I can create a triangle out of this. Here, that will be a vertical line. And then this will be a horizontal line, and that is 90 degrees. Okay? Now, if that point is 3 comma 7, then we know this horizontal line is 3 units long, and the vertical line is 7 units long. And when I do this, I've also created an angle theta there. And so now I can very easily find what r is, right? Because I can do the Pythagorean theorem. So now, if I wanted to find sine of theta, I know it'll be that red one over r, and then the cosine will be the horizontal one over r, right? Okay, now, suppose I didn't know exactly the coordinate of that point. Suppose instead, all I know is that that is a point at x comma y. So now, this side is just x. It has a length of x. And this just has a length of y. And so now, right, if I wanted sine of theta, it would just be y over r. Cosine would be x over r. Tangent would be y over x. And then secant, cosecant, cotangent would just be the reciprocals. And so this is something that we just need to know. When we do this, right, when we have a point anywhere and we draw the angle, right, or the radius, theta is always going to be the angle between the radius and the x-axis. And when you do that, every single time, the opposite side is going to be the vertical side. The adjacent is always going to be the horizontal side. And so if sine is opposite to hypotenuse, it's always going to be y over r. Cosine is always going to be x over r. And so now when we know that, that means we no longer need a diagram like this, right? So if I just take any coordinate point, I can use just the x and the y coordinates, and I can find my trig ratios. So let's just do this here. Take a look here. Negative 4 comma 3 is a point on the terminal side of an angle in standard position. Find the values of the 6 trig functions. So immediately I say this is x and this is y. What I need is r. R is the square root of, 3 squared plus 4 squared. So r is 5. So immediately that's what you have to do, right? There is no need to draw a diagram. So now, sine of theta, I know is always y over r. The y coordinate here is 3 over r. Cosine of theta is always x over r. The x coordinate is negative 4 over 5. Tangent, y over x, negative 3 over 4, right? All this without drawing a diagram. Now, just for this one, if I did draw the point, okay, right here, your angle again is always right here between the x-axis and the terminal side. So now you can see again, right, that the y value is 3 and the x value is -4. So cosine is -4/5. Sine is 3/5. But we never draw this. Okay? All right. So then cosecant is 5/3. Secant, -5/4. Cotangent, -4/3. Any questions? Yeah. No. But it slows you down, right? And usually in pre-calc honors and the assessments, there is like not much time to slow down. Okay, now this works for any point, right? The point we did it twice now, happened to fall within a quadrant, right? And so what we did here, y/r, x/r, y/x, right? This has, because it's math, this has to apply for all points anywhere. So now what if a point didn't fall inside a quadrant, but it fell on one of the axes? In that case, we call that a quadrantal angle. But the process that we do this can't be different just because the angle falls on a line, right? So let's see how that looks. If the angle is on one of the axes, it's a quadrantal angle. So now, take a look at this one here. So suppose it's 0 degrees, right? That's the point. Suppose that's the point, right? What would be a proper coordinate point for that point? Well, suppose this was like 1 unit over, right? What would that point be? 1, 0. And what would r be? The distance from the origin to that point? 1. Okay? So a point here, like let's just come up with a coordinate point, 0, 1, right? What would r be in that case? 1. So when we always choose the ones, r also becomes 1, and it just makes it easy for us, right? So here it would be, let's say, -1, 0, and so on. So let's do the same thing for the first one, 0 degrees, that we were doing. Sine of theta here, okay? Remember, sine is always y/r, 0/1, 0. Okay? And then cosine, instead of writing generic theta, what would the angle be over there? 0. So cosine of 0, remember we said it's always x/r? X here is 1/1, 1. Yeah. And then tangent of 0 is y/x, 0/1, 0. So now, what's cosecant of 0 then? Undefined. And secant, 1, and cotangent, undefined. Okay? Now, here, I'm not going to do all of them, but let's just do a couple. Here, the angle is 90 degrees. Sine of 90 degrees, remember sine was always y/r, 1/1. Okay? What about cosine? Cosine is always x/r, so what would it be in this case? 0/1, which is 0. Now, why don't we keep the coordinate generic? Let's just keep it, like for this point, let's just say the coordinate is -r, 0. How long is the radius then? It's r. It's r. R is a distance. The distance from here to here is r, right? So r is r. Okay, so now sine of 180 then is 0 over the radius 0. Cosine, right? It's the x coordinate over r. How much would it be? Negative r over r, negative 1. Okay, hang on. I get paid for this. Let me do this. The coordinate here is negative r comma 0. So that's x comma y. And how much is the radius from here to negative r? R. So now, sine of 180. Remember sine we said was y over r? Okay, so the y coordinate over r, 0 over r. Cosine is x over r. The x coordinate over r is negative r over r. Okay, so what would tangent be? It's y over x. That would be 0 which is? Okay. Why do you make it negative 1? Because you can make it negative 1, or you can just keep it generic and say, just like we said, we have a point here, x. You can also say this is a point negative r, right? Okay. Yeah. Here, at 270 degrees, the corner is 0, negative r. So what would sine be in that case? Negative r over what? Always never over 0. It's y over r. So how much? Negative r over r. So negative 1. Okay, what would tangent of 270 be? Negative r over 0, which is undefined. Okay? So what we need to remember are these. Okay? Sine is y over r. Cosine is x over r. Tangent is y over x. Yeah.
So if the line was like let's say 300 degrees, you'd still be doing like the trig functions for going all the way around.
Yeah.
Okay.
Yeah. Yeah. Either. Okay. Okay. So let's do this. Find the exact value. This is how you'll normally be asked this, right? Find the exact value of this. So we need to find cotangent of 7 pi over 2. 7 pi over 2, this is 7 over 2 pi, which is like 3.5 pi. So if I start here, 2 pi, 3 pi, and a half pi were here, right? So so this is a quadrantal angle, okay? A sample coordinate point there would be what? Okay, so either 0, negative r, or 0, negative 1. Okay, let's use the ones, because we practiced a little bit with the r's. 0, negative 1. Now, cotangent, remember, is x over y. So in this case, 0 over negative 1, 0. Okay. Tangent of 450. So we start here. I go 360. I have to go another 90 degrees to 450. What would be a proper coordinate point there? 0, 1. And tangent is y over x, undefined. Okay? And it's got to be super quick. Okay. Well, no, we're gonna end up doing all of them. Just wait until this lesson is over. Okay. So, okay, let's talk about the unit circle. Okay? All right. Now, the unit circle is a circle with a radius of 1, and it's centered around the origin. So now, if the radius of this circle is 1, right? Let's think about this for a minute. So remember how we had our special triangles, 30, 60, 90, and this was 1, root 3, and 2, right? If this hypotenuse is 2, it can't fit in there. Okay, don't draw this. But if that hypotenuse is 2, it would look like that, right? The radius of this is only 1. A triangle with a hypotenuse of 2 would look like this. That doesn't fit in this. So what we need to do is we need to rescale that triangle so the hypotenuse is 1. That means I would have to divide this by 2 and then proportionally divide all these by 2. Okay? So now I get another triangle where this is 1, that's 1/2, and that's root 3 over 2. Okay? So now, why is that a good thing to do? Why does that matter? Remember SOHCAHTOA, right? Like whatever. So look, sine is opposite over hypotenuse, right? If the hypotenuse is 1, do I need to divide by 1 every time? No. So then, if the hypotenuse is 1, instead of doing opposite over hypotenuse, I can literally drop the h's. And so sine will just be the opposite side of a half. Cosine will just be the adjacent side of root 3 over 2. Okay? So when I now try to fit that triangle in here, first of all, it does fit. Look. Okay? So now if this is 30 degrees and this is 1, yep, this is a half. This is root 3 over 2. So now, if I'm on the unit circle and I want to find sine of 30, all it is, remember sine is always the vertical side. All it is always the vertical side of that triangle, which is a half. Okay? So that would just be a half. Right? If I wanted, 60 degrees, how would 60 degrees look? Okay, so let me draw a 60 degree here. Okay? Right. It used to be that it was like this, so this will be root 3 over 2, and this will be a half, right? So if I have a 60 degree angle there, right? Now this is root 3 over 2, and this is a half. So I'm like, okay, what's the sine of 60? Just root 3 over 2. Okay? It's okay. You don't have to draw this one. Okay. Let's take another one. Let's take 2 pi over 3. 2 pi over 3 is in this quadrant here. Okay? 2 pi over 3 corresponds to what angle? 30 or 60 degrees? 60. So that's the big angle there. And so now, when you draw a triangle, the sides of this triangle are 1/2 and root 3 over 2. So now look, if I want to find the sine of 2 pi over 3, sine is always the opposite side, root 3 over 2. But then the cosine of 2 pi over 3, because it's to the left 1/2, is negative a half. Okay? Okay. I want to do a quick review of these angles. Just make sure everybody knows the pattern. Yep.
On the triangles, what would it look like on the bottom two quadrants? of the 60-degree.
So we're going to do them, but like here, it would be, let's say, negative 1/2 and negative root 3 over 2, right?
Okay.
And positive 1/2, if it's here, and negative root 3 over 2.
Okay, so the 60 degrees on there would be more like 30 degrees from the up-facing line, like the vertical line.
Right, but we never look at the vertical line. We always look from the horizontal, from the x-axis.
Can I remove the vertical line?
Like the y-axis?
Yeah, and just put a dot at the origin?
You can.
Okay.
Okay, so take a look. Let's look at, okay, so the angles that correspond to pi over 6 are these. Right? So you should know, okay, that's straight too. Okay, so you should know what the pattern is for each of these, right? So look, these are all the angles that correspond to pi over 6. Pi over 6 is like 30 degrees. So these are all the angles that are that many degrees away from the x-axis. And the way in which we remember the pattern, remember we've done this last year, we start with pi over 6. The coefficient here is 1. 1 pi over 6. Then we're going to increase the coefficient and see which ones don't cancel or don't reduce. So for example, 1 pi over 6, then 2 pi over 6. Do the 2 and the 6 reduce? So we throw it away. 3 pi over 6 reduces, throw it away. 4 pi over 6 reduces. 5 pi over 6 does not reduce. That's the next one here. 6 pi over 6 reduces. We don't want that. 7 pi over 6 does not reduce. 8 pi over 6, 9 pi over 6, 10 pi over 6, all reduce. 11 pi over 6 does not reduce. That's the next one. So if I start from here, it's 1 pi over 6, 2, 3, 4, 5 pi over 6, 7 pi over 6, 11 pi over 6.
So should I write this?
Okay? It's up to you. Just remember the patterns. Okay, let's remember the patterns.
Okay.
So look at all the pi over 3s. 1 pi over 3. The next one that doesn't cancel is 2 pi over 3. 3 pi over 3 cancels. 4 pi over 3 does not cancel, then it's 5 pi over 3, right? So that's how we do all these. Okay? All right. Who remembers what reference angles were? Reference angles. They're important. Okay. Let's talk about reference angles and then we're going to put it all together. Okay. Reference angle is an acute angle which lies between the terminal side of an angle and the x-axis. So look, here's an angle that, there's no need for a reference angle, but that would be it. Okay? Look at this one. Suppose your angle is 120 degrees. The reference angle is always the angle between the terminal side and the nearest x-axis. So the whole thing from here to here would have been 180. If this is 120, how much is that? 60. So that's 60 degrees. Okay? So for reference angle, we use theta prime 60 degrees. Okay? It's just a notation. It's like an accent. Okay, so take a look at this one. Suppose I have here an angle of 200 degrees. Reference angle is between the terminal side and the nearest x-axis. So if this much was 180, that leaves how much for the reference angle? 20 degrees for the reference angle. Here, let's say it's, 300 degrees. Reference angle is between the terminal side and the nearest x-axis, not over there, here. How much is the balance there? 60. So we say theta prime is 60 degrees. Don't memorize this. Reason it out, because then it gets confusing. And plus, we don't need more things to memorize. Yeah.
Wait, just a reminder, there's no negative.
Correct. It's an acute angle, which means 0 to 90. Yeah.
What would the use cases be for a reference angle?
Okay, you're getting ahead of me. Hang on, you're fast forwarding. Yeah.
What if the angle is 60 with the reference angle is 60?
Yeah, there is no need for a reference angle because it's like it's its own reference angle. Mm-hmm. Yeah, there is no need because then it's a quadrantal angle. There's no need for it. Yeah. Okay. Here we go. Sketch and find the reference angle. All right. To sketch an angle, guys, this is what I want you to do. Draw X and Y axes. You have to show me the initial side. You have to show me the direction of your arrow and the terminal side. 3 arrows. What's the reference angle here? 30 degrees. Right? Because it's right here. 3 pi over 4, what quadrant is it in? 2. Okay. You guys ready for the big secret of trig? For these angles in radian, if it's reduced, if it's a reduced angle, the reference angle is just pi over that denominator, right? Yeah. Yeah. Because it's like, it's got to be a full pi, right? From here to here, it's a full pi. This is 3 pi over 4, then you only have 1 pi over 4 left. Yeah.
Do we have to show that, or can we just make sure that we keep that in the...
Well, it says to sketch. Yeah. Okay. Yep. Quick. Yeah.
So, when it's a reduced angle, it's pi over the denominator.
Yeah. Okay. You know, I'm gonna skip this for the time being. Let's put this all together. Okay? I need to find the exact value of each of these expressions. Are you ready? This is the big idea why we're doing this. So, Yeah, I'm going to skip that chart because it slows us down. We're not going to do this. Okay, so look. Okay, tangent of 11 pi over 6. Here's what you need to do. First, figure out where it is. Okay, 11 pi over 6. Let's figure out where it is. So remember we said 1 pi over 6, 5, 7, 11 pi over 6 is here. This is where 11 pi over 6 is. You guys really don't want to miss this, okay? Now, we want the tangent of this. Tangent is y over x, remember? So now, how much is the y side of this? Yep. Negative 1/2. How much is the x side of this? Root 3 over 2. So this is negative 1/2 over root 3 over 2. So that negative 1 over root 3, that's it. You don't have to rationalize it. Okay?
Is that negative?
Negative 1 over 2, root 3 over 2. So look. Okay. Look. Let's clarify something. On a 30, 60, 90 triangle, right? This is always going to be 1. And then there are two legs of a triangle. The legs of the triangle for a 30, 60, 90 only have two possible sides. The half, the root 3 over 2. So in this case, clearly this is the small side, it's a half. Clearly this is the large side, it's root 3 over 2. So when I see this, I'm like, okay, small side 1/2, large side root 3 over 2. This goes down, so it's negative. Now, let's do, I'm going to do all of these, but I'm going to skip around, okay? Let's do D, sine of negative 300. Negative 300 is here. Yes? No, I'm skipping. I'm going to this one. What angle is this? 60 degrees. So now look. This is the long side, root 3 over 2. Correct? Is sine vertical or horizontal? Oh, I thought you were raising your hand. Is sine vertical or horizontal? Vertical. So this is root 3 over 2. Okay? Doesn't matter because this is going up. Okay. We're not going to use that because it's going to slow us down. Because if it's 300, the reference angle is 60. Okay, listen, guys, let me do all of these. And then if you still have, like, let me just do a couple. Okay, let's just do a couple. Cosine of 120. So 120. Okay? What angle is this here? Reference angle. 60 now. So we are looking at this, right? Now, we want cosine. So this is the triangle we're looking at. We want cosine. Is cosine horizontal or vertical? Horizontal. Is this horizontal, the big or the small side? Small. Is it positive or negative if we're going that way? Negative 1/2. Cool? Okay. Let's do the next one. F. Let's do 4 pi over 3. Okay. So look. 1 pi over 3. 2 pi over 3. 4 pi over 3 is here. Is that the big or the small angle for the reference angle? Big, yeah. Is it an emergency? Okay. Big angle. So now, is sine vertical or horizontal? Vertical. So now, is this vertical side the big or the small side? So how much is it? Negative root 3 over 2. You see that? Another way to look at it is the following. If I wanted to get to this point, right, how would I get there? I would have to go left a little bit and down a lot more. Down is the vertical, which is the sine, so it's negative root 3 over 2. What would the cosine be there?
It would be positive, right?
It would be negative because you're going left.
Oh.
Negative 1/2. Yeah.
Oh, the tangent would be positive.
The tangent would be positive because it'll be negative over negative. Okay, so now let's go back up. Actually, let me do C. Let's do C. And this is why, okay, when I teach it for the first time in Algebra 2, I really stress like doing it this way because it really is like a very efficient way of doing it as you go into higher math where you have very little time to do all this. Okay, 9 pi over 4. First, we need to figure out where 9 pi over 4 is. Okay, so let's see. Look, it's like a clock. Okay, 1 pi over 4. Then what's the next one? 3 pi over 4. And what's the next one? 5 pi over 4. 7 pi over 4. 9 pi over 4. 9 pi over 4 is here. What angle does that correspond to? 45 degrees. Now look, For the 45, 45, 90, it used to be, it used to be 1, 1, root 2. But to make this a 1, what do? Divide by root 2. So for the 45, 45, 90, the sides are the same, and they're each 1 over root 2. So now, cosine, it would be 1 over root 2. Okay? Because remember, we want to make the hypotenuse 1? Yep. Okay, 15 pi over 4. Okay, where is 15 pi over 4? So remember, this was 9 pi over 4. What would the next one be? 11. And then, oh, you guys are jumping over these numbers. 13 and then 15. Okay, imagine jumping from 9 years old to 15 years old. You don't want to do that, right? So here we go. Secant. Is that like the sine or the cosine? Cosine. I mean, in the case of the pi over 4, it really doesn't matter. What is the cosine of that angle? 1 over root 2. Yep, it is. It's a 1 over root 2. So then what would the secant be? Root 2. No, because remember it's cosine, so it's positive going this way. The x is positive going this way. So 9.
Oh, 11, 13.
Right? Cosine positive that way, and then sine is negative. Oh, yeah? You don't believe me. All students take calculus, also cosine is positive.
Which one is A? And all students take calculus?
The first one.
Wait, does that apply to all these?
It does, but it slows us down. That's why I'm like, just see, if you're going to the left, if you're going to the right and up, it's positive. If you're going to the left and down, it's negative.
Use like reasons.
Right, exactly. Right?
But if you're not drawing it out,
Yeah, exactly. Okay, which one didn't we do? Secant of 270. Where is 270 on here? Quadrantal angle. Here. What's a good corner point there? 0, -1. Okay, secant, what is that like? Cosine. So what would this be?
0.
It's undefined because there's no extra side.
Okay, so listen. The cosine here is 0, right? So cosine of 270 is 0. Secant is 1 over 0, undefined. Okay, no negatives. Okay, now, oh, look at that. Last year, I stopped at the same place, apparently. Okay, so now, this is important. We are going to stop here. You are going to do homework number 3 due tomorrow, Friday. However, you are going to skip 33 and the ending. Okay, remember this was a 2-day lesson. Like this one, 67 to 83. So skip these. This is due when? Tomorrow. Okay, and then I'm going to teach the rest of this. And then Monday, what do you have on Monday? A quiz. Yay.